Hello developers, welcome to Comparing Java REST API Frameworks. Today we're going to take a look at Micronaut, Quarkus, and Spring Boot, how to build a REST API with them, and how to secure all three applications with OAuth 2.0. I believe that these three frameworks represent the future of Java, especially on the server side. And one of the reasons is because they can all become native applications, and that means they start up very fast and can be used in a lot of different environments. I work for a company called Okta. I'm a developer advocate there, and a unique thing about me is that I love Java and JavaScript. That's not that popular these days. I grew up in the backwoods of Montana with no electricity, no running water. I had to walk 1.5 miles to the bus stop every day, and it felt like it was uphill both ways. I live in Denver, Colorado with my beautiful wife Trish, my two awesome kids, Abby and Jack. I also have a middle child. His name is Hefe. I bought him off eBay in 2004 and spent 14 years restoring him. Now he's pristine, and he's got a 911 engine, so he sure is fun to drive. You can tell I have an expensive obsession with Volkswagens. I also have a Synchro Westie that we bought in 2013, and that's been great for adventures and all kinds of fun stuff. If you have a similar obsession with Volkswagens, I'd love to talk to you about it. In this talk, we'll cover several things. First of all, we'll talk about why Java versus other languages or other frameworks, and then we'll also go into how to build a Java REST API or GraphQL API with these three frameworks. And then we'll touch on securing your APIs with OAuth 2.1 and building applications with Docker as well as with GraalVM. So you might be asking, why Java? Well, first of all, this is a Java conference, so it makes perfect sense that you are a Java developer and you're watching a talk on Java. One of the things I like to point out versus other platforms or other frameworks is we've had 25 years of success in Java land. Use, abuse, and improvements have come during that time, and now at the 6-month cadence, things are happening much faster. It's open source, the code is available. There's many popular open source projects like Spring and Hibernate and many others that have made it successful throughout the years. It's hugely popular and widely used. So many enterprises and web scale companies use it, including Netflix, eBay, IBM, Microsoft, my company Okta, VMware, Tesla, and Apple. So if you're a Java developer, there's lots of opportunities for you. Now to get started with Java 15, which is the latest and greatest, just released on September 15th, you can download it from OpenJDK, or you can download it from Adopt OpenJDK, and those are just different places that they've built the binaries for the actual JDK. So you can also use SDKman, which I love. It's as easy as installing with curl, and then you can do this command SDK install Java and whatever version you want to use. So it's great for switching between JDKs. It also allows you to install things like Groovy and Scala and Kotlin, and then even Grails, or Maven, or Gradle, Spring Boot, and many other libraries. So you can see that Java 15 represents the 6th feature release as part of the 6-month cadence, and for over 2 years this level of predictability has really allowed developers to more easily manage their adoption of innovation. Now that doesn't mean that people are getting off of Java 8, but they're starting to, and one of the great things that the start.spring.io folks did is they made Java 11 the default, and I believe it's the default for the other frameworks mentioned in this talk as well, Micronaut and Quarkus. This talk was inspired by a blog post by Daniel Perita on the Okta developer blog. Developing services in Java, including REST APIs, wasn't always easy and productive until Spring came along and changed the landscape. Many years have passed since then, and new frameworks have emerged in the community. One of these frameworks was Micronaut. It's developed by OCI, the same company behind Grails, and their goal is to help developers create microservices and serverless applications. There's also Quarkus, another framework that gained popularity over the last year. Developed by Red Hat, Quarkus promises to deliver fast startup and less memory usage, two common problems when developing REST APIs in Java. In my personal opinion, these are the top 3, and that's why I'm discussing them. If you want to add your framework into here, you can. I'm just not going to do it in this talk. Who cares about startup time? Serverless is just someone else's computers, right? Can't you get around this by just leaving your applications running and your JVM warm? Yes, but with pay-per-usage, serverless can save big companies a lot of money. And when you're big, you don't want money flying out the window. So to get started with Micronaut, it's pretty easy. Using SDKman, you can install it with SDK install Micronaut. And then you can create an app with the mn command, that's for Micronaut, create app, give it a package name, and it'll use that last part of your package name as the app name. So in this case, it's app. When I first tried this back in January, you could use Micronaut, but now they don't allow that as a name. And then you specify the build tool. If you don't specify anything, you get Gradle, the default. And then -F is for features. So in this case, we're going to add security as we create the application. If you're more of a visual person, you can use Micronaut Launch, which is available at micronaut.io/launch. You've created your project. Now you need to add a REST API. So in this example, I'm just going to add a simple REST API that returns the user's name, basically says hello to them, kind of like hello world, but in a secure fashion. So you can see here we have a controller that's at /hello. It's secured, so the user has to be authenticated, and we're just going to return a plain text response. And then from the Java security principle, we're just going to get the name and return that to the user. So for Micronaut JWT security, you need to enable security and JWTs or JOTs, then provide a URL to the public keys that can be used to verify signatures of your JWTs. If you're familiar with JWTs, you know that they have a header, claims, and a signature, and those keys are just used to validate the JWT locally. Micronaut supports the RFC 6750 bearer token specification for transmitting JWT tokens. So you have everything set up, you're ready to go. So at this point, you've built a secure Micronaut application, and we need to test it. One of the tools that I recommend is HTTPie. It's hard to say because you want to say HTTPIE, but it's HTTPie. And it's an alternative to curl that does like JSON by default, pretty colors, a lot of cool stuff like that. So you can install it with brew, install HTTPie, and then how it works is you just run HTTP, and you can use -v if you want to get verbose response, but you're just hitting a URL. And then you can put, you can post, you can do pretty much anything you can do with curl, and it works great that way. So to test this Micronaut API with HTTPie, you can first run it with mn:/run, and then you can test it with HTTPie, basically hitting that hello endpoint, and you'll notice it defaults to localhost. And so you'll get a 401 response that says, hey, that doesn't work. And then you can set a token, and I won't go into the details of getting that, but you can talk to me or read the blog post, and it shows you how to get an access token. And then you can pass that token in as an authorization header. Well, when you do that, you get a success, and it actually prints out the user's name. So here's an example of me running this, where first of all I hit it, and you'll see I get a 401, and then I set that token, and then I do it again, and this time it says hello to matt.raible@okta.com. So that's how you set up a basic REST API with Micronaut. Not too difficult, right? With Quarkus, the start command is a little longer, and this is because they use Maven and the Quarkus Maven plugin to do it. So you'll see you run a create command, you specify a few parameters for your group ID, for your artifact ID, and then you'll have a class name for your main class, and then you can add any extensions, for instance JWT in this case. If you're a visual person, they have a browser-based starting point at code.quarkus.io, and you can make all the same decisions there. To create a REST API, you'll be using JAX-RS, and you'll see all the imports there from JAX-RS, and we're basically having a path of /hello, public class hello resource. It's available at the get method, has to be authenticated, and then it produces that plain text response. So a little more annotations, but still very straightforward, and gets the user principal and then prints out their name. For microprofile JWT security, there's two properties that you need. One is the public key location, and the other one is the issuer. So that all makes a lot of sense, but not really. Because here's the thing, if you go and look up the issuer, it has a JWKS URI in there. So I think this could be an improvement on microprofile where they could actually just have you specify the issuer, and then you go look up the public key location, since it's already there. To test with Quarkus, same, very similar to Micronaut. First of all, you use their command to build and run in development, nvn compile Quarkus dev. And the cool thing about this command is you can change any Java class, any template, pretty much any file in the system, and Quarkus will restart without you doing anything. And so the other frameworks are trying to get there, but Quarkus is the best one at that, in my experience. So then you'll hit the endpoint, you'll get a 401 token, same thing as before. This is an example of doing that. You can see that it returns with a 401. Also has a www authenticate in there to indicate that you do need a bearer token, so that's a nice little hint. And then once you pass in that bearer token, then everything will work and you'll get your name back. Pretty slick, huh? Now with Spring Boot. Right, with Spring Boot, you can use HTTP to actually go and create an app, and so that's pretty slick because they have an API and endpoint that you can talk to. And you'll see I'm passing in dependencies as web and Okta. We have an Okta Spring Boot starter that validates JWTs for you, and then the package name and the name, and it downloads a zip. There's also start.spring.io. They were one of the first ones to actually have a website where you can go and download a brand new project. So that's been around for about 5 years now, maybe more, and used and loved by many developers around the world. And so Spring wins the contest for the longest class name. You can see that their imports are huge. However, it also requires the least amount of code. So you can see we just have 3 imports. We have a get for hello, and we have a REST controller that just returns a string. So no need to specify the type or whatever. It just knows that from, the return type. And then to set up a Spring Security OAuth 2.0 resource server, you can use the Okta Spring Boot starter, and we combine the Spring Boot security starter, the OAuth 2 client, the OAuth 2 Jose for validating tokens, and the Spring Security OAuth 2 resource server. So the Spring Boot plugin puts all those so you have less dependencies and less properties to manage. And it only needs 1 line of configuration. You can see there, Okta OAuth 2 issuer. And it works with Spring Webflux, so it'll detect if you're using Spring Webflux instead of Spring MVC, and all that just works right out of the box. So again, to test, you'll do Spring Boot run, and then hit it with HTTP. And the biggest difference that I've seen is look at those security headers. So even when you get a 401, it has all kinds of security headers set, and when you pass in that authorization header with the access token, it still has a lot of XSS and other security headers in there. So Spring Boot kind of wins on the security headers front, and I'm sure the other ones will catch up. Spring Boot's been around for a lot longer. Now that you've learned how to create a Java REST API with all 3 frameworks, let's look at some comparison points. One of the things that people like to bring up is the startup time. In development, you should be able to run, MVN Spring Boot run, and it starts up, in a couple seconds. And you'll see from this graph that it starts in just over a second for Spring Boot. Now, Quarkus is a little bit longer with compile Quarkus dev, and I did compile everything beforehand, so I wasn't really compiling new classes. And I use the numbers that these frameworks print out when they start. So the Maven process can take a while, but really what the servers and what these numbers are is just when it actually starts up. So you can see Micronaut is the fastest, and then Spring Boot is the slowest, especially when things are packaged up. The interesting thing about Quarkus is it's faster when it's packaged as a jar than when you're running it from Maven, which is different from the others. You can also build GraphQL APIs with all 3 frameworks. So why would you want to use GraphQL? Well, GraphQL is kind of unique in that the client can just ask what it wants for. So instead of hitting a REST API endpoint and getting back a full object, it can query for just a few fields in that object. So of course, your REST API could have similar things where you pass in some parameters and filter it, but it's baked into GraphQL by default. So a lot of people like it for that. It's used by big companies like Facebook and works well for them. Does your favorite framework support GraphQL? Well, Micronaut, that's a checkbox. It does. And it actually has a guide for it, so it's built into the framework. It's an extension that you can install and use. Quarkus, same thing. MicroProfile has a GraphQL feature that Quarkus implements, so it's using MicroProfile. Now the interesting thing here is Spring Boot has support as well, so it checks that box, but it's not part of the actual project. It's not core to Spring, and they don't actually maintain it or do anything related to GraphQL. So I could see that being something that they might add in the future. Right now you can use this GraphQL speaker, that's how you pronounce it. So it's GraphQL Schema, Publisher, and Query Resolver. And we have a blog post on that. I just published a video today on the OctaDev YouTube channel that you can watch if you want to see how to do that with Spring Boot. So you've learned how to build a REST API with each framework, and I've shown you that they all have GraphQL support. Well, what about security and OAuth? OAuth, and particularly OAuth 2.0, it often feels like you're trapped inside a maze of specs and trying to find your way out before you can finally do what you set out to do, is just secure your application. So the main goal with OAuth 2.1 is to capture the current best practices in OAuth 2.0 as well as its well-established extensions under a single name. So what's in OAuth 2.1? Well, here's the major differences between 2.1 and 2.0. PKCE, or Proof Key for Code Exchange, is required for all clients using the authorization code flow. Redirects must be exact, no wildcards or anything like that. The implicit grant, where access tokens are passed through your browser's URL, is no longer allowed. It's being omitted. as well as the resource owner password credentials grant. And that allows you to just do username and password, which kind of bypasses the whole point of OAuth, but it's built for legacy clients. And then bearer tokens, you can't use them in URIs, and refresh tokens must be either sender constrained or one-time use. So you can read more at OAuth.net/2.1. And so one of the things that people don't realize about OAuth is it's just an authorization protocol. It doesn't have anything to do with authentication. So back when OAuth first started, many companies like Google and Facebook were using it, but they wanted to get users' information. And so there wasn't a standard way in OAuth to do that. It's not authentication, it's just authorization. So they would actually establish a /me endpoint, and then they would use the access token to talk to that. So what happened was that wasn't standard, and they wanted to make it standard, so they developed OpenID Connect. And this doesn't really have much to do with OpenID. I mean, that was a previous standard, but it's housed at the OpenID Foundation, so that's where OpenID Connect comes into play. And OpenID Connect basically will allow you to, using that issuer, to look up like a lot of information about the authorization server, and then log the user in, and give back an ID token, and establish a user info endpoint similar to that /me, that you can get more user information from. And so that became a standard in 2014, and so there's no real thing as OAuth 2 login, but there is OpenID Connect login. So the question is, do these frameworks support it? Because what you saw in the previous demo was just a resource server. And so there's no state, it's just validating a JWT token. And one thing you might want to do with these frameworks is establish a login. So when you hit the app, it redirects to an authorization server, they log in, comes back, and you have identity information as well as an access token. So that's what OpenID Connect gives you, and all three frameworks support it. So Micronaut has a guide for it. It's an Okta guide, so I like that. And then Quarkus has support for OpenID Connect as well. And instead of doing 2 properties, you do like 4, and you add an OIDC extension, and then it all works. Spring Boot calls it OAuth 2 login. Like I said, it's more like OpenID Connect login, but it works, and it's part of Spring Security. So what about testing? No one writes tests, do they? Well, Spring Security has great testing support, but they've been around forever. And the OAuth stuff that's in Spring Security only got added a couple years ago. So the others might have testing support, but as far as I know, Spring Security has the best testing support. They even have the ability to just pass in like you can do JWT with a static import, and boom, it all works. So that's great. I didn't dig into the other frameworks much, but developers don't like to test anyway, right? Now let's get into Docker. So to build a Java application with Docker, it's usually pretty easy. You can create a Docker file and then build from that. And so in this case, what this Docker file expects is that you've already built your application. You have a jar sitting in the target directory, and it's ready to be packaged up. There is ways to take this Docker file and actually have it build your application as well, but I just like the simple version here. And so once you have that Docker file in place, you can Docker build and then Docker run to run it. You can also use Jib. If you don't want to use a Docker file, Jib will basically inspect your pom.xml or your gradle.build, and it'll know how to build your image. So it's much more efficient, and it gets better over the long run. So at the bottom of this slide, you'll see a link to the Jib project on GitHub, and if you want to use it in your project, all you need to do is add it to your pom.xml or your build.gradle, and then you can run nvm verify to build your project and run all your tests, and then Jib build, and that'll build a local Docker container. But you don't need a Docker daemon running too. You can actually build it and deploy it directly to your Docker daemon. So if you have that on Google Cloud or Docker Hub, then you can easily just build it and send it right there. So when you generate an application with Micronaut, you use that mn create app, it generates a Docker file in your root directory. Quarkus generates 3 Docker related files. So it has a fast jar, it has a JVM, it has a native one. So the fast jar is optimized for size. The JVM is optimized for running on the JVM with java-jar, and then native is for building GraalVM containers. And Quarkus also supports Jib. So it's pretty cool that you can do Quarkus add extension and then pass in the extension, and boom, it all works. So Spring Boot has built-in Docker support as of 2.3. So if you're using a version past 2.3, I'm using 2.3.4 in this example, then it all just works. And it uses layered jars for faster builds. So it starts with your dependencies, your snapshot dependencies, because those don't change much between builds. and then your resources, and then your application itself. So to go native with GraalVM and Micronaut, you can use Micronaut CLI. So if you're creating a brand new app, you'll just pass in -f GraalVM. But there's a really cool feature that I just learned about yesterday, mn feature diff. So you can pass in a feature that you don't have. It'll print out new files that need to be added, dependencies that need to be added, and it's really awesome. Like, it's a great feature. I love it. And so once you have that, you can run nvm package, and then there's a script that it creates for GraalVM that you can run that Docker build. So with Quarkus, GraalVM support is built in, which is awesome, right? You can actually package your app, use the native profile from Maven, and then pass in Quarkus native container build true, and then build the image using that dockerfile.native, and then run it. Now, using the examples we had and the application we created for Quarkus, it will fail when you're on nvm package, and that's because there's a test in there that expects that hello endpoint to return a 200 and to return hello. Well, now that you've secured it, it's not going to do that, so you can change the test to return a 401 and a blank body, and then it'll all work, or you can use -d skip test. So to go native with GraalVM and Spring Boot, this actually is part of 2.4. So Spring Boot 2.3 doesn't have it, but it's in milestone versions of 2.4. So you'll first upgrade to 2.4 M2 at the very least, and then you'll update your configuration to avoid proxies. You can see that proxy bean methods equals false, and then you'll add the milestone repositories to your pom.xml, and then you can configure in the Spring Boot plugin the configuration for the image. So you'll see here we have an end that says BP boot native image to 1, so it says triggers that on, and then some build arguments. The most important one that I found is that -- enable HTTPS. Without that, you get a Java security no such algorithm exception, RSA key factory not available, and so you're going to need that to do any sort of security stuff in your application. Then you'll add the Spring GraalVM dependency and build your native application just like you would your Docker container. So when you've configured your Spring Boot plugin to have those parameters in there, it'll build a native image instead of just a regular Docker container. And then you can run your native Spring Boot app using Docker run, and it actually blows up with the Okta plugin. So I created an issue for this. The error is that configuration classes need to be marked as proxy bean methods, and the Okta OAuth 2 resource server autoconfig doesn't do that. So when this first happened to me, I was like, well, the Okta Spring Boot starter is just a wrapper around Spring Security's library, so maybe if I get rid of it and just use Spring Security, it'll work just fine. So I changed it to use Spring Security's resource server dependencies instead of the Okta Spring Boot starter, and then I set the quite lengthy property instead of, Okta OAuth 2 issuer, it's Spring Security OAuth 2 resource server JWT issuer URI. And I set it to the same value, and what I found was it still didn't work. So I got closer, like the app started to start up, but the error I got was cannot convert value of type string to a security configurer, and I basically updated this ticket here so it has all the information in there. So if you wanted to take a look at that and try to figure it out, then it's there. So currently Spring Boot doesn't support building a native image, or it supports building it, but it doesn't actually start with GraalVM. So Spring Boot 2.4 probably will. I'm sure we can fix our Spring Boot starter before 2.4 is released, so it will work, and of course Spring Security might have some work to do as well, because in this example, in this workaround, I never used Okta at all. I just used Spring Security's raw libraries. And so to look at those containers and how fast they start up, Spring Boot isn't in here. Unfortunate, but I couldn't get it to start with Spring Security in there. So Micronaut starts up in 26 milliseconds, and Quarkus is in 13 milliseconds. So I ran it, 3 times on my 2019 MacBook Pro with 64 gigs of RAM, and those are the numbers you got, which is awesome, right? The fact that it starts up in 13 milliseconds, or even 26 milliseconds, it's so fast you can barely blink. So great work on those. And I'm sure Spring Boot will catch up, and it'll be awesome by the time 2.4 is out. So some community comparisons. I always like to do these pretty graphs, which a lot of people hate, and that's why I'll go through them quickly. So most of these are just pretty graphs and should be taken with a grain of salt. But the thing that you should remember is the age of these frameworks. Spring Boot has been around since 2014. That's over 6 years, almost 6.5 years. April 1st, they released it on April Fool's Day. Quite bold, don't you think? And then Micronaut was October 23rd of 2018. So almost 2 years old. Quarkus was November 25th, 2019. Not quite a year old. So a lot of these numbers don't really add up because Spring Boot's been around for so long. So, Stack Overflow tags. Most people have problems with Spring Boot, right? 91,000 tags. Well, the others, there just aren't that many questions for them because they haven't been around that long, but I'm sure they might catch up. Spring Boot has such a head start, though, you never know. And then GitHub stars. You can see Spring Boot's been around for a long time, but the others do have a fair amount of stars, so you might be asking, well, what about the growth? Are they growing faster than Spring Boot? So there's this great site called star-history.t9t.io, and what it allows you to do is look at GitHub star growth. So you can see, even though you might think that Micronaut and Quarkus are growing faster, based on GitHub stars, Spring Boot is still, up and to the right. Jobs aren't that many for Quarkus or Micronaut, but lots of Java jobs, right? You just might have to, start with Spring Boot and then convert them to Quarkus or something like that. Another from website is hotframeworks.com. So this is more for web frameworks, but these all can be web frameworks, right? They are web APIs. That's what REST is. And on this list, only Spring shows up. They're at number 9. It's not Spring Boot, but it's Spring. And they just combine Stack Overflow and GitHub scores. And then the interesting thing is jhipster is 26. You might be saying, what is jhipster? Well, jhipster is a project that I work on that actually helps you develop a Spring Boot backend and an Angular, React, or Vue frontend. But the cool thing is we have this concept called Blueprints that has support for Micronaut and Quarkus. So the Micronaut Blueprint is available on GitHub. It's had 15 releases so far. You can see it's not at a 1.0 release, so the authors of the Blueprint aren't that confident that it's ready for prime time, but I think it is. It's got 12 different contributors and 289 commits. It still needs NoSQL, reactive microservices, and GraalVM image support. Quarkus is on GitHub as well, and it's only got 7 contributors, so about half, and half as number of releases, and not as many commits. So that project could certainly use some work, and there's been some people ramping up and trying to fix those issues. So that needs Gradle, OAuth, and OIDC, which I worked with Joe White on last week, NoSQL, reactive, and microservices. I do believe that Micronaut is ready for prime time because I wrote a blog post on it and I verified everything worked. So this is from August 17th, 2020. One of the unique things about the Micronaut blueprint is it's supported by OCI, the company behind Micronaut. So we haven't really received individual contributions from Spring Boot or Quarkus and their committers, but I've received a ton of help from the Spring security team on making OAuth and OIDC work within jhipster. So I don't want to say they're not helping, they're just not helping directly. And maybe they're not as motivated to make jhipster popular because they don't see front-end frameworks being that great, but who cares, right? The Micronaut one is great, works well, and I'm sure the Quarkus one will get there someday. So action. If you're new to Java, try Spring Boot. Because the docs and the Stack Overflow questions, there's a lot of information out there, and they maintain backwards compatibility, so even though a question might be 5 years old, you still might find the answer you're looking for. If you're familiar with Spring Boot, you might want to take a look at Micronaut or Quarkus. They both have migration paths, so they've been able to leverage that and actually have Spring extensions or the same annotations or things of that sort, so you don't really have to learn new annotations. You can just use the ones you've been using with Spring Boot. Testing is important. Even though I had a blank slide for testing, I was kind of just making fun. Invest early and often. Make sure you have tests so you don't have to fire up HTTP every time you want to test your API. Quality is important. And in that same vein, design your apps with security in mind. Use OpenID Connect for authentication. Use OAuth 2.0 for authorization, or 2.1, because friends don't let friends write authentication. I write a lot of tutorials as well as the rest of my team on the Okta developer blog. So if you're interested in any of the topics I've talked about today, especially Java, check that out. We also are on Twitter at OktaDev and YouTube at the same. If you want to learn more about security, particularly in a microservices context, you might want to check out my blog post on security patterns for microservice architectures. So thanks for coming today. You can contact me via my website at raibledesigns.com. My direct messages are wide open on Twitter. You can find this presentation on SpeakerDeck, and most of the code that I write these days is on Okta Developer. So if you go to the Okta Developer on GitHub and search for Java REST API comparison, you'll find the repo with all the code that I used in this talk. So thanks for coming, and may the auth be with you.